Alright, now for tutorial question 6, okay, to solve the first inequality, x plus 1 divided by x minus 1 is greater than 6 over x. Okay, so what we'll do now is to subtract both sides of the inequality by 6 over x. Okay, so please do not cross multiply, okay, because now we are looking at inequalities and we do not know for sure the sign of the denominators for each expression. Okay, so find the common denominator. So I'll get x squared plus x minus 6x plus 6, alright, divided by x times x minus 1. Okay, so let us further simplify this. Okay, we should get a quadratic expression in the numerator. Okay, factorize the numerator to get x minus 2, x minus 3 over x minus 1 greater than 0, and take note of the values we need to exclude. In this case, 0 and 1. Okay. From here, multiply both sides by a suitable expression, positive expression, so we would multiply both sides by x squared, x minus 1 squared on both sides. Okay, so it will simplify to a polynomial inequality as follows. Okay, so we will sketch the graph out on the number line. So the roots are 0, 1, 2, 3. Now, because 0 is already one of the roots, so in this case we have to use other arbitrary values. So what we can do is we can use negative 1. So at negative 1, when x equals to negative 1, the left hand side would be negative 1. Okay, so let me write this part here more clearly. Okay, multiplied by negative 3, multiplied by negative 4, multiplied by negative 2, which is positive. Alright, so we will start off somewhere here. Okay, and it will cut each of the root naturally. Okay, so we now have to exclude all of them because it's a strict inequality. Okay, and also because at 0 and 1 is undefined. Right, so our final conclusion would be 0 is strictly smaller than x is strictly smaller than 1, or 2 is strictly smaller than x is strictly smaller than 3. Okay, I believe I made error here in the graph. So when x equals negative 1, the left hand side is positive, right? Okay, so the graph is wrong. Let me resketch this part. Okay, and the conclusion as well. Okay, so just to correct it, we should start from here instead. Alright, so it should look something like this. Okay, so our conclusion should instead be x is less than 0, or 1 is smaller than x is smaller than 2, or x is greater than 3. Okay, so what we now have is the answer for the first part. Okay, now for the second part, we are now asked to show or to solve each of the inequalities. Okay, this and this. Alright, so we can use substitution for each. So in this case, maybe for part 1, we'll let y equals e to the power of x. For part 2, we'll let u equals to modulus x. Okay, so from part 1, okay, by letting y to be equals to e to the power of x, alright, we actually get y plus 1 over y minus 1 is greater than 6 over y. Okay, so now take note that once you have performed substitution, before you can use the final solution from the first part directly, please check to see that this expression here you have obtained, that the one that you have obtained, okay, is a direct replacement of variable from x to y from the first inequality. Okay, if it's not clear that it's a direct replacement, you will need to manipulate your second inequality to show it clearly. Alright, as we have done in tutorial question 4 for the second part. Okay, because for the second part in that question it was not clear that it's a direct replacement of variables. Okay, so from here it's a direct replacement, so we can simply conclude that y must be smaller than 0, or 1 is less than y is less than 2, or y is greater than 3. Alright, then we will put back e to the power of x each time we see a y. Okay, now for the second and the third part of this solution, okay, we can take ln on each side of the inequality, because we see that the numbers here, okay, the constants here are positive constants. Okay, so we can take ln. So taking ln, what we should get is ln 1 is less than x is less than ln 2, or x is greater than ln 3. Okay, whereas for the first one, the constant on the other side of the inequality is 0. So in this case, you do not take ln on each side. Okay, instead, you need to use an argument regarding the exponential function. Okay, in this case, you see that e to the power of x is always positive. This is a number that's always positive. In other words, this part of the solution will have no solution. So you will have something like no solution, or ln 1 is less than x is less than ln 2, or x is greater than ln 3. Okay, so the final conclusion would be 0 is less than x is less than ln 2, or x is greater than ln 3. Alright, now for part 2, we let u to be equals to modulus x. Okay, this will simplify our inequality to u plus 1 over u minus 1 is greater than 6 over u. So this will give us u to be less than 0, or 1 is less than u less than 2, or u greater than 3. Okay, so we replace back again with modulus x. Okay, so similarly as we have seen from part 1, the first part of the inequality should have no solution. Okay, because modulus x cannot be negative. Alright, now for the second and the third one is slightly trickier. Okay, for the second one, modulus of x is between 1 and 2. Okay, so you can think of modulus of x to be the magnitude of x. Okay, so for what values of x, alright, do you see that the magnitude of x is a number between 1 and 2? Okay, so you observe that for this inequality, okay, this only occurs when negative 2 is smaller than x is less than negative 1. Okay, because we know that in this region here, the magnitude of x, okay, will be between 1 and 2. Or 1 is smaller than x is smaller than 2. Okay, whereas for the other inequality, we'll get or x to be greater than 3, or x is less than negative 3. Okay, so if we were to sketch all this properly on the number line, okay, so what you should see is the following. Okay, let me repeat. What you should see is the following. Okay, so we will sketch the solution we have obtained for each part of the inequality on the same horizontal line. Okay, so the first part here, if this is inequality 1, okay, this will correspond to this part. on the number line. Alright, now whereas for the second one, it will be corresponding to this part. Okay, so actually we have already stated the final solution. Okay, but you just draw the number line to make sure. Okay, why is this actually already the final solution? Because when we take OR, we are taking union. In other words, every time we see one line, okay, as long as there's one line, okay, that will be part of the solution. Okay, at least one line. So our final answer would be, in order x is less than -3, or -2 is less than x is less than -1, or 1 is less than x is less than 2, or x is greater than 3. Okay, so do expect sometimes your final conclusion may be quite tedious to write. Alright?